will start. It's a lot of people. This is very nice. I would like to welcome Luka Piškorec to this lecture. Luka has been a collaborator of us, of Matthias and myself, for many years. He studied at ITA Zurich, so he's an architect by education. Then this was 2011, I think. You graduated. He came to us very quickly. We remember him, really doing physical stuff. He was also very engaged in the pig roasting, team. So he was not just about algorithms and data and things like this. He did a lot of digital fabrication. He was helping or build up with others the MIS digital fabrication. This year's MIS students are here. And on the side, he has always been an architect. We remember also his sketchbook. He was continuously sketching, and we had an argument sometimes, during meetings, saying, could you put the sketchbook aside, because we're not so sure if you were fully concentrated on the topic. He also during this time he set up a practice, Studio 10, with partners, so an international practice research crossover. Maybe we'll tell something about this at some point. This is still existing. The fact that it's online and international helps, because at a certain point Luka went to Helsinki, moved to Finland with a lecturer position, and disappeared. And this was when? This was
2017.
17, yeah. But we have loosely stayed in touch, and also through Petrus and other people that we knew what we were doing. He set up a family there. He settled down in the north, and probably half a year ago we started a discussion on email. And then I learned that he did many things there. He started a PhD, and so on and so forth. But he told me that he was now, during the lockdown, the pandemics, probably they're there in the darkness of the north. This is even more, you need to find something new to look into, and he started to do generative art and to look into blockchain, to look into these mechanisms. And he also said that this was a completely new planet, and this was open up also new perspectives for architecture we never thought about. And since Matthias and myself, are also starting to look into metaverse and the virtuality of all these things that now after 30 years, start to become really real again, and could start to affect architecture as a parallel reality. And of course, all these things are very much linked to these technologies and mechanisms. How you exist, how you value stuff, how you make sure that. And at the same time, I must admit, and it's probably a problem of generation, I feel probably as uncomfortable hands-on with blockchain as my parents felt about the internet, 30 years ago. And I said it would be good to invite him here and give us sort of a talk, an insight perspective from, I think, the point of view of the architect. And this probably helps a lot, if it's not a data scientist, a cryptograph that talks about these things. Probably forgot one or two things, but it's fine. I'll ask you to start the lecture, and you have as much time as you want.
Try to keep it within 1 hour.
Perfect.
Okay.
Thanks.
Thank you very much for coming. MS students, PhD crew. Actually, there's a crew from the blockchain and distributed ledger systems group from Uni Zurich. I see people from Objects, the Tezos platform that I'm also publishing on or using, and you will see some work also that you can that is published there as well. So yeah, without further ado, so there's going to be a few parts of this lecture. I'm going to go through some basics of blockchains. So that's a bit first part. I'll give you a little bit of a kind of rundown of why I think this technology is very important and kind of how I sort of got into it, and sort of a little bit of perspectives on it. And then the next part is going to be about generative art, a little bit kind of the overall context there, and then some of my specific work, specifically in related to artificial morphogenesis, which is sort of also part of my PhD at Aalto University. So I kind of merged my PhD and let's say artistic work. And last year I founded Protocell Labs with a colleague, Kane Borg from Finland. So we are two guys who run Protocell Labs, and basically many of the works that you will see came from there. And as Fabio said, 2015 we founded here with a big group, 10 Studio, and talk a little bit kind of my context, my work basically from that context as well. And we will also finish with kind of AI imagery, so kind of the some of the tools that we also used, and to show you a little bit how I used it in my work. Okay, hopefully it will not be too boring. Okay, so the context is I'm currently at Aalto University, a lecturer there. Actually just got a permanent position. I run with all my passion Protocell Labs, and also part of 10, which is a bit of a bigger group. Just a little bit about 10. So we are a group of something like, it's like 12 people, but basically we are mostly architects, and mostly based in Zurich, but we have outposts all over Europe. I'm one of the outposts in Finland. And currently 10 is organized as a Verein, so in Switzerland, but also as an actual architectural studio. So we do actual projects, but we kind of pool in the knowledge from many different disciplines. So here I have kind of an overlap a little bit between people and sort of expertise. And we kind of see ourselves as a record label. Okay, so we collaborate on individual projects and always create kind of small nuclear teams and try to pull in the expertise from different members in these kind of nuclei. And we basically started with this work already pre-COVID, so we were very distributed. Today we have a Discord server where we are communicating and doing our work primarily. We also have a physical location in Zurich. And then the COVID hit and we just continued working. So it didn't really affect us. The remote way of working didn't really affect us. Yeah, we also have many collaborators that come from different disciplines. This is mostly related to just the jobs that are being done. So in architecture, as you know, you need to have a lot of experts. And basically my part in the group is to work on really design research. So there are like a couple of projects that I will show that kind of feed into this whole story. There's also websites here that you can visit. Okay, first part, digital assets protocol. So what is a blockchain, or what does it enable us? Digital money and programmable economy. I'll go a little bit more into kind of detail what these mean and why they are in a way so different and revolutionary. Okay, so digital money is basically Bitcoin white paper 12 years ago already, and Ethereum white paper for programmable economy, smart contracts, and so on 8 years ago. Just going to play a short clip here.
But you know, I think about this, and what about this internet thing? Do you know anything about that?
Sure.
What the hell is that exactly?
Well, it's become a place where people are publishing information.
Right.
So everybody can have their own homepage, companies are there, the latest information. It's wild what's going on. You can send electronic mail to people. It is the big new thing.
Yeah, but you know, it's easy to criticize something you don't fully understand, which is my position here.
Go ahead.
But I can remember a couple of months ago, there was like a big breakthrough announcement that on the internet or on some computer deal, they were going to broadcast a baseball game. You could listen to a baseball game on your computer. And I just thought to myself, does radio ring a bell?
Okay, so I think the context of this clip, it's made 30 years ago. So you have David Letterman, who in a way, you know, kind of a complete layman, and a little bit making jokes about this new technologies that came in. And Bill Gates, arguably sort of the most, well, the smartest man in the world at that time, even he didn't really know the full potential of internet. That's why he couldn't really explain it. Also, this kind of brings us to this problem of significance of technological building blocks can be hard to predict ahead of time. And you can see that across history: electricity, transistor, internet, blockchain. One example, when Edison built a light bulb, he was told it's an electric candle. I mean, he called it an electric candle. And then the main the main question was, but why do I need an electric candle when I have a normal candle? Okay, I can put oil and I can light up my room. But of course, you cannot build in the information age using wax candles, but you can with electricity. And same thing with your own transistors and the kind of the internet, sort of the digital economy is built on top of internet. And somehow the idea is the blockchain is just an extension of that, and we cannot really predict all the use cases in the future. Okay, so the early internet is built as an information transmitting network. And the kind of the question already from like early on was basically you transmit the information, but how can we transmit value, or how can we prove ownership over something? You can't really have a functioning economy if you cannot somehow deal with value. Okay, and you know, I mean, I'm old enough to know, you know, pirated copies in the 90s and so on, so how you could kind of naturally prevent people from copying digital files. Okay, so so kind of how do you protect, in a way, how do you prove ownership over something that's digital that can be infinitely reproduced? Okay, so in a way, the blockchain as a protocol was in a way envisioned by Satoshi Nakamoto as a protocol for transmitting value and proving ownership. And that's really the gist of it. If you don't remember anything from this first part, this is what you should remember. So in Web 2, current web server that we have, you know, you don't really own anything. There's a protocol, you use it, you put videos, pictures there, you put your own data, but you don't really own it. And this you can of course find out when you read the terms and agreements from all the services that you're using. But somebody is owning everything you make, okay? And the idea is in Web 3, the internet is kind of basically provides a basis for programmable digital economy, and you can actually be an owner, okay? So we can have economy because you can own something. And just a little bit distinction, there, internet is said to be a skinny protocol, and blockchains are said to be kind of fat protocols. And skinny protocols, so that's, you have basically a small protocol layer and a fat application layer. Also, all the value is accrued in this application layer. So think of Google, Facebook, Twitter, they're built on top of the internet protocol, and that's where all the value is. You cannot own shares of the internet, but you can own shares of Google or Facebook. In blockchain, you have the reverse situation, okay? You have the fat protocol layer, so that's Bitcoin, Ethereum, Tezos, and so on, and kind of a relatively maybe skinny application layer, meaning you have apps that are built on top, which carry value but kind of less value. That's maybe Coinbase, Uniswap, decentralized exchanges, and so on, FX hash. Okay, in a way this enables us then to own digital assets, but nobody owns or controls the ledger that facilitates these ownership rights. Few key points. Decentralization works, okay? Blockchain is kind of a distributed ledger. Think of Wikipedia versus Encarta. Who of you knows what Encarta is? Encarta was the Microsoft's encyclopedia. Yeah, don't worry about it. And open source works, okay? So proprietary, so you know, 30 years ago we had proprietary cryptography, but today we have, you know, HTTPS, or so we can kind of communicate securely over the internet without worrying that somebody's kind of eavesdropping on our transactions. And this cryptography is open source. Okay, there was a lot of work by certain people in the 90s to actually make this happen. It was not a given thing. Okay, blockchain as a database is usually slow, but also secure, permissionless, transparent, and immutable. Okay, and then we have assets, or digital assets. So blockchain is a database for creation, storage, and manipulation of digital assets. That's it. Okay, and they are basically tokens. So these assets are tokens. Sometimes I will talk about assets, sometimes I will mention tokens, but I really like to use the term assets because they relate better to kind of what is it all about, okay? And they are managed by smart contracts. so on smart contract blockchains like Ethereum, Tezos, Solana, and so on. And these assets are just stored in this internal storage of the smart contract, and they're accessible through mapping functions. I promise I will not harass you too much with code, but I think it's kind of just interesting to know that, you know, you basically use solidity. So that's on Ethereum, you have a mapping between token ID and the address, and that basically, you know, it says this address or this identity or entity owns token number this, and that's it. There's just a mapping. There's a hash map, hashable database in the background. Okay, and what exactly is an NFT? Or it's a non-fungible token, represents whatever the creator declares, and they're in a way ownership certificates. Okay, and as ownership certificates, we can basically tokenize virtually anything. These are just from last week. You know, tokenization of a house. So the only difference is that there's no, in order to prove ownership, I don't use my signature and my, you know, ID with the picture to prove that I'm the owner, but I use a digital signature to prove that I'm the owner, and the contract just exists on the blockchain. So in a way, it's not really that far off. And then sometimes tokens or NFTs can be used as placeholders, or so you have either one or the other one. So it represents a physical asset, but you can either hold a physical asset or the NFT. You cannot have both. So you can get the physical asset by burning the token, or get the NFT by, in a way, destroying the physical asset. In this case, Damien Hirst, the British artist, kind of used this in order to let his collectors basically choose which one they want, and then ceremoniously, in a way, destroying the physical pieces. Okay, so assets the ownership is kind of recorded on the blockchain, but the data itself, what the token actually is, so it's a digital file, has to be somehow also stored. And then it can be stored on-chain or off-chain. And due to various reasons, basically, most of the data is stored off-chain. So 90%, for example, of NFTs are stored off-chain, because the storing things on a blockchain is actually very expensive. And it's also inefficient. So so you cannot really, for example, store a JPEG image on the blockchain. This doesn't really work. But maybe if it's a code that generates an art piece, that you can store, because code is in a way a compact representation of this of an image or some kind of digital, let's say, entity. Okay, and then in that sense, the NFT platforms distinguish themselves. For example, FSH, which is on Tezos, uses off-chain storage. Artblocks, very proudly uses on-chain storage, so on Ethereum. And then one other point that is really crucial here is that off-chain storage is actually also decentralized. So there is something called EPFS, the Interplanetary File System, and that's basically a way, it's like a torrent network. If you ever downloaded movies from torrents, that's how it works. So it's a peer-to-peer network. It's uncensorable, because you can always be your own node, and so you can always serve the file to the world. You basically cannot be censored, and basically all the kind of large digital files can be hosted in a decentralized way. Or so you have a blockchain, you have decentralized storage. They work in tandem. This is very crucial for EPFS, for NFTs. Okay, if you have off-chain storage, then only the token metadata is stored on chain, and this is basically how it looks like. This is just one example of from a Verizon platform, which is a Tezos platform. This is one of our pieces. This is how the metadata looks like, and I just highlighted here the owner blue on top, and orange ones are basically links to the decentralized storage. So it's they're addressed not by location but by content. Okay, so basically hash a file, and you get a unique identifier, and you can use this to decentrally, or use storage files in a decentralized way. So you're not, when you're accessing a file, you're not asking where it is, or you're not indicating location, but you're basically describing what the file is. And then this decentralized network basically makes sure to fetch it for you from whatever location it will be stored. It can be stored on multiple nodes. Okay, and then some of the arguments are, well, I can kind of just, what's the point of all of this? Because I can kind of just right-click save. It's a right-click save argument. Your file. Anyone can copy the NFT you own, but actually, no, you can't. You can copy the digital file associated with it, but the token itself, you cannot copy it. I mean, it's publicly displayed, and you can only transfer ownership if you own the private keys, and you can perform a digital signature. Okay, so the ownership cannot really be just hacked in that sense. It can be phished from you, but it cannot be hacked. Okay, so there's somehow separation between the ownership token and the digital file, and that's a little bit weird if you think about it. But if you think about it long enough, it also starts making sense. Okay, smart contracts are immutable. Okay, so and basically they are, or in a way, they are immutable only as far as their smart contracts allow them to be. I'll just name one example. So the famous Bored Ape Yacht Club contract. You can go here in Etherscan and have a look at it. You can see the whole code. It has two functions. Basically, you can, the owner of the contract can set the provenance hash and set the base URI, which basically locates all the images of the apes. And in a way, it just constructed a small kind of a Bored Ape Yacht Club self-destruct procedure. So you can basically, you could in theory just change the whole collection, the art of the whole collection, and then transfer the ownership to a burn address, and you basically wiped out 1 billion market cap collection. Okay, so so in a way, this would be kind of the opposite. You could actually make it immutable if you wanted. You would transfer it. You could transfer the ownership without changing the location of the or where the URIs kind of point to. So the whole point here is to just show you that even though some things are immutable, again, it just depends on how you construct smart contracts, and that's why there's so many hacks happening, and you can read about them because somehow code can contain bug. Okay, so in that sense, immutability implies permanence. The assets cannot really be deleted. You can only transfer their ownership to somebody else, and including a burn address, which is in a way makes the tokens irretrievable. And one other feature of this is that the tokens, there's a certain resilience of the NFT kind of ecosystem. Example from Hic-et-Nunc, which was a very popular Tezos-based platform, art platform, and in November 11th last year, their owner, or the owner of the platform, just decided to shut it down. But it took a few hours until mirror sites were put up. So the front end was taken down, but of course the tokens still exist on the blockchain and they could not be removed. So if you can basically set up your own mirror site and, for example, Teia DAO just took over the stewardship of the platform. So it's in a way more decentralized, okay? So it couldn't be really taken down. Okay, some side notes, identity. So kind of the idea blockchains also enable us to have digital identity. So in a way, you have a private key and public key. That's enough for you to, in a way, to authorize yourself online in a secure way. In a way, in Web 1, we had kind of no way to authenticate anybody. That's why internet was a very dangerous place. You could meet weird people and you just didn't know who they are. In Web 2, we have authentication through social media, which is great, but it's, again, centralized. You have to use Meta or Google. In Web 3, we have authentication through a private key. Okay, so it's a decentralized way to authenticate yourself. And this enables pseudonymity. So we can have multiple digital identities that cannot be linked to each other. Okay, so this kind of gives us a whole different way to exist and interact online, and that's why many, it's called famous people, famous artists in the Web3 space, we just don't know who they are. But okay, so this, we embraced the pseudo-anonymity as a concept. Okay, I'll bore you just a little bit with math. Just want to explain a little bit how hashing works. So that's this irreversible determinism, just one underlying concept. So hashing is a process, deterministic process of transforming arbitrary long string of data into another one with a fixed size. And this is an irreversible process, okay? So in irreversibility in math, very simple. Actually in hash functions, addition is used, but for example, modulus function is more common. If I give you a and b, you can give me a sum of a and b, but if I give you a sum, you cannot give me actually what the a and b are, okay? So I cannot go from a sum back to its additive components because there are just infinitely many. So that's one simple example of irreversibility in man. So even the simplest functions can be irreversible, and basically what hashing does, it maps infinitely large or data that has, like say, approximately infinite. It can be arbitrarily large, okay, whatever fits in our space on our computer, and it maps it to a space that is this large, okay, so smaller space. And it does this in a deterministic way, and good hash algorithms actually don't have any collisions, so it's infeasible to produce hashes that kind of or to find data that produces the same hash. Okay, these are called hash collisions, but for good cryptographic hashes, it's impossible. Okay, so we can translate any data into hash string, and this is then easily manageable. Has a lot of applications, and I just want to show you, for example, when we talk about mining, so blockchain mining, proof of work on Bitcoin, or until recently on Ethereum. What does it actually mean? It actually means finding a hash of the block, so transaction block, finding a hash that is smaller than a certain arbitrary number, or that's specifically difficulty. And how do we get a different hash? We just change something in the data, and this is determined as a noun, so a number that we use once. We iterate through that number. Here I needed in 38 iterations to find first zero. And for, again, Bitcoin and previously Ethereum and some other proof of work blockchains, you need quite a lot of zeros in front. Okay, so this I found by hand, but basically that was the most that I could find on my laptop. Okay, so this is basically how you perform mining. That's a kind of crucial. And hashing is then used for cryptographic security, digital identities, data retrieval in hash tables. So completely blockchain unrelated, proof of work mining, and also randomness in GenArt. Okay, so I just wanted to geek out about that a little bit. Okay, GenArt. So when I entered the art world, there was this idea that kind of the art itself cannot be defined. You cannot kind of put it into words, because as soon as you define it, somebody else can find something that could be considered art, but it's outside of that definition. It's a little bit similar, like the concept of Tao from Tao Te Ching. Cannot really describe it, but still, I would like to kind of point out certain things that I learned about art, or generative art specifically. And here I'm directly quoting Tyler Hobbs, who is a very famous gen artist and kind of a leader in the field, in the sense of kind of in the discourse. So when you talk about gen art, you talk about long-form generative art. So in a way, we are not designing a single object, we are designing a collection of objects. And curation happens on an algorithm level. Okay, so we cannot really control the outputs, and we cannot pinpoint the good outputs. We basically are only providing the algorithm, and then the collectors usually are the ones who mint the pieces, and they are the ones that just get a random piece. So you have to make sure that your algorithm doesn't produce any bad results. And maybe the argument from, at least in the words of Tyler Hobbs, the success of his Fidenza collection was exactly that he kind of spent months on kind of fine-tuning the algorithm. So that's a little bit different than what we had maybe previously, where in a way you would use code to create outputs, and then you could sort of curate them more. But in this long-form generative art, this is in some sense not allowed, or also not possible. Okay, and just one other quote from him for all of you to bear in mind. I think I mentioned it today at the desk read in the morning. There's an excellent essay from Tyler. Intellectualism has hampered generative art. So in a way, because of our backgrounds, we take the easier route of considering our work in primarily technical terms. And this is actually very hampering to, or detrimental to generative artwork, okay? So in a way, we should sort of instead maybe focus on visual communication. That's kind of really what matters. And of course, I think that's also the beauty of computational design, and also what you do here maybe at ETH is in a way balancing these two things, okay? So really using code to basically enhance your design agenda, but technicalities are not the mean in themselves. Okay, they're just or they are not the end in itself. They're just means to the end. Okay, so that's kind of a little bit of perspective. Okay, here we're going to quote also Marshall McLuhan's 4 laws of media that actually apply to gen art: enhance, reverse, retrieve, obsolesce, and for example, retrieve. Okay, the new media brings back some features of earlier media. So we talk about kind of traditional art, maybe gen art. Retrieval means that sometimes gen artists actually imitate traditional media. Here are 2 examples: lineage and mining structures. These are from the Tezos platform FXhash. So in a way here, this is completely computer generated, but it's made to resemble basically analog styles of pencil. And in a way, the opposite of that would be kind of the first law, enhance. So the new media enhances, makes possible, or accelerates some things. And here are 2 examples from 2 other artists also available on FXhash and on Object, Kim Asendorf and Carsten Schmidt, aka Toxic. Okay, so this is just shader code. And then I just want to show you, when I talk about kind of gen arc or generative architecture in this context, I just want to show you a few projects from other people, just to give you better context, and then you can maybe also better contextualize maybe with my art or my work. Reborn, so basically a collection of, I don't have the exact number, but of kind of these ideal city plans. Hollow, very successful collection, maybe in my opinion, maybe also even the most successful kind of generative architecture projects in the space. These are all available on FXhash, also the Tezos platform. These are actually animated, so they are generated in the browser. Okay, so they're just rendered and generated directly on your screen. Another example, Brutalist, and I cannot name the collection, but it's from Landlines Art. Okay, so these again, you're basically creating a collection of objects, and every individual piece is a token that you can own. You can mint it, and you own it, and you can resell it. So there's a primary market, secondary market, a little bit similar to the traditional markets. Ismailio's work a little bit more kind of alien space plans. Okay, a little bit just talk about the market. Okay, so there is something called art provenance. It's a documentation that basically authenticates a particular art piece. So in traditional art, this would be kind of, you know, who was the creator, ownership history, appraisal value. This is just basically documentation that you have that kind of proves that your work is original, and you know, where does it come from, and so on. And the trick with NFTs is that they have perfect provenance, because everything on the blockchain is visible. Okay, so that's kind of that makes basically NFT market fully transparent, for better or for worse. And for worse, I'm going to show you how it looks like. So you basically see a collection. These are Crystallics collection. We'll see a little bit later. Also on FXhash, you see pieces that are sold. What is the total primary market volume, secondary market volume, all the transactions. So I think in a traditional art market, this is not really a desired property, because usually you want to kind of mystify a little bit how the sales are going. So you want to separate these 2 things, kind of the art and the market. But yeah, this is in a way unique to the NFT markets, and this doesn't really exist in the traditional art. Okay, so in a way, anybody can see how successful you are, or not successful, at least in the kind of market terms. Okay, and then the other issue is this IP rights, so intellectual property. So you don't really own IP. The IP rights don't really get automatically transferred to you when you buy the NFT. So that was always kind of a criticism, but this is not true also for traditional art. Okay, so if you buy a Picasso, I own the art, I own the picture, but I don't own Picasso's IP. Okay, there's an organization that owns the IP, and I just took a kind of quote here that specifically says, what do you own when you own a Picasso picture? Okay, so this is in a way same as in traditional art, that you own a token, but it's not really clear if you own what else do you kind of own? All right? And then different NFT collections and projects, they handle this in different ways. Some completely transfer the rights to the token holders, and this is called the copyleft kind of principle, where I call it the celebrity principle. Okay, so you know, who of you never heard of Mona Lisa as a painting? Probably, yeah, okay. I would say probably everybody heard about Mona Lisa, but for example, I never saw it in person, okay? Never saw it in person, but that means I saw a copy of Mona Lisa. So kind of this idea that what makes a celebrity person or a celebrity art or whatever object is the amount of copies, okay? So if you have a lot of copies, this kind of increases, doesn't decrease the value of the original, it actually increases the value of the original. And then that's a little bit kind of to think about when, you know, somebody tells you, well, NFTs you can just copy. Yes, you can copy, but there's only just one person who is the owner of the original token, you know, and actually these copies don't diminish the value even more, they might even kind of increase the value. Okay, a little bit about math. So 2020, as Fabio said, I was in a dark forest in Finland, and I kind of spent more or less a year writing a book called Mathematical Principles of Computational Design, and left it in a draft form. But basically, I started kind of gathering topics from math that I think would be interesting for students of computational design, because I hold this course called Algorithmic Design at, in Helsinki, and I started listing these topics, so kind of really compiling them, and you can't actually see it, but and yeah, huge list, and basically at one moment I kind of had to stop. These are just figures from the book, so it's in a draft form. If anybody's interested, I can pass it on to you. Potentially the book will never be published because life. But basically this gave me a little bit of an overview of what is there, you know, outside of, you know, tools that I was using before, like in Rhino, Grasshopper, and so on, Voronoi, you know, diagrams. So, and then I started to really make this kind of an overview of, you know, which math is interesting, and, you know, kind of how does it relate to design or art, you know? So you have kind of geometry, it's in a way mathematics of shapes. Algebra, mathematics of manipulating symbols. Analytical geometry and algebraic geometry is kind of mathematics which actually relates these two things, relates shapes and algebra. Okay, so that's kind of interesting. And linear algebra, mathematics of transformations. And we can in a way think of all geometry as just a linear transformation of its most basic element, which is the point. Okay, so I start with the point, I can get a line by translating the point. Then I can get the plane by translating the plane. I can get the volume by translating the plane. Yeah. So I can start with a simple element and just transform it. So using linear algebra, and I can get whole geometry. That's kind of also the basis of. That's kind of the connection between all these. Okay, and then somehow graph theory, mathematics of relations, graph algebra, so mathematics of manipulating graphs. So it turns out graphs actually have an algebra on top of them, which makes them very convenient to manipulate, and that was kind of in a way for me the starting point of my PhD and also kind of the creative work. And somehow for me, mathematics provides a framework for seeing and understanding the world, which is logical, consistent, and I would argue extremely flexible. Usually people would think that math is extremely rigid, but you know, I can always have different proofs for the same theorem, which in my point of view proves that math is actually rather flexible and it's kind of a creative discipline. Okay, I cannot talk too much about this, but I made a YouTube playlist with lectures that go into many of these topics. This is actually for my students, and you can go online and look at some of these. Some of them are tutorials, some of them are lectures, and maybe two that I would take out are this algorithmic design introduction and fundamentals. So where I kind of expand a little bit more on these topics if you're interested in that. I would warmly recommend this. Okay, and then GenArt tools. So what are the tools? It's a web browser. Okay, so I studied here at ITA and also was teaching, and we just use Rhino, which is kind of a proprietary software, so you have to buy it, and then you have kind of your CAD environment, CAD framework. There's certain convenience there. You can use Python to code and program geometry inside, but the web browser can do the same thing. Okay, so it's in a way a portal to the digital universe. And in a way, GenArt is made for the browser. Okay, it's its natural habitat, and browser it's a cool concept, okay? Okay, so generative is generated through code and displayed directly in your browser. It's basically a web app, okay? And JavaScript is basically the current lingua franca of browsers, so that's why I had to kind of learn JavaScript. Some tips if you want to start with this in 2D P5.js. It's basically processing, but for the browser. So for JavaScript, use kind of Canvas API, which is every browser supports it. Or in 3D, you can use 3GS, which is WebGL and shader languages like GLSL. It's a bit more advanced, but you can basically do 3D real-time animations in a browser as well. Okay, this is not my example, but I have a source below. This is shader code. Okay, so this is it. Okay, so this shader code produces this outcome. And this is another example. Okay, so it's super compact. Shader math is like very mind twisting. And it basically, shader code executes on your GPU, and it's basically, you define the code for every pixel. Okay, you're basically telling every pixel what it does, and this parallelization enables the speed and also somehow this deceptive simplicity. Okay, through kind of very little shader code, you can get amazing results. And yeah, again, spent a whole year sort of learning from people that do this very, very well. But it's just, the point is that just because you used years maybe drawing or coding in, you know, Rhino, Python, Grasshopper, maybe Blender, there's a whole world out there that I would urge you to explore and to kind of expand your mind into. Okay. Artificial morphogenesis, that's basically how I kind of started with my work. I was obsessed with lattices for very long. This is from basically all my sketches, I call them notes from the Book of Sand. Started first drawing them by hand and then just generating them. Yeah, just kind of generating them through code. Small digression, kind of how I started with lattices. We had this research project where we used basically lattice encoding. So we published a paper in 2020, which is called Generation of Geometric Interpolations of Building Types with Deep Variational Autoencoders. Okay, so we used autoencoders to basically encode wireframe geometry. And you have wireframes and you can basically encode them onto a kind of latent space, so we use variational autoencoders. And we use something called parametric augmentation, so you usually kind of augment your data, so you take a smaller data set and train your network on a larger data set that you get from the smaller one by something called data augmentation. And here it's done parametrically in Rhino, so we call it parametric augmentations. We create many of these lattices from those different building types in this case, and then we just kind of merge them together. They form one data set, and then we train this variational autoencoder on it, and then we can create sort of we can create outputs there. Okay, so this is a form of a generative neural model. Okay, and then these wireframes you can turn into 3D, and this was kind of I can't really focus too much on this, but the idea was to use machine learning techniques and apply them basically on create kind of a generative model and really work with three-dimensional geometry. Okay, I also did some 3D prints there. And then somehow the next step was when I kind of realized that wireframes are basically graphs, or they can be described partially, or their topology can be described through graph structures, okay? And graphs have an algebra defined over them, and that's kind of quite cool. Okay, so different ways of representing graphs. I'm going to show you always this kind of adjacency matrix, but it's basically just saying there's a node as a label, and it's connected to some other node. And you don't necessarily need to have any other information. You can feed more information. You can say, well, there's a connection, but there's a certain weight to that connection. But you can also just have a simple like directional graph or undirected graph where you just establish there's a connection between some nodes. Okay, and then there are different types of elementary graphs. This is like our alphabet, our grammar, or actually our alphabet. So path graphs, planar graphs, and so on. And we can use them as building blocks. And then we have elementary graph operations, so we can do something to the graph like add vertices, remove them, add edges, remove edges, okay? Then there are some unary operations like create a complement graph or create a line graph or dual graph. Then there are graph products. That's where things get really interesting. So you can take two graphs and create a product of them. So these are just a list of all the products. Like Cartesian product is maybe the most useful because it produces architectural looking lattices, let's say. So, and yeah, maybe I use, in the examples that you will see, I use mostly Cartesian product and strong product. And I will not bore you with the math, but it's basically, there's, for example, a Python library called Network X, which is used for complex network analysis, and you can just use that to do all of these. So you just define the operations, you don't need to really calculate anything. The library does everything for you, okay? There are different ways of connecting these graphs together. And, but then you just have a graph. And then the question is, that's not a lattice, okay? So in order to get a lattice, we need to embed the graph in space. So it's called graph embedding, or sometimes called graph drawing. And if a graph has an algebra defined over it, then my argument is then if we embed it into space and we get a lattice, then this lattice has also algebra defined over it, okay? So that's kind of, these are the lattice algebras. Okay, so there are different types of embeddings. So you can have one graph, you can embed it in many different ways. So it's not a straightforward solution. But one way is using this force-based embedding. So it's basically particle spring model. And you just kind of simulate your nodes as particles that have repulsion forces and certain attraction forces. So there's a repulsion between all the particles, but attraction between only some of them, okay? Where the links are established. And then the theory goes, at one moment, if you do this in three-dimensional space, the lattice will reach an equilibrium. Okay, so we're going to have an equilibrium state, a lattice in space. And these are just stills. So you go from adjacency matrix to basically a graph. I'm going to show you a lot of videos. So this is a part of this unfoldings collection and morphogenesis collection. So unfoldings is on Object and on the Theia, originally on Hikanuk, and morphogenesis is on Version. These are all Tezos platforms. Okay, so this was just first experiments. So every video that you see here is actually a token that you can go and purchase or mint. Okay, so these are just some initial examples that I did. We're basically just taking some sparse matrices and just kind of trying to generate lattices from them, just to kind of have some data to sort of visualize. But then I kind of really started working with sort of these elementary graphs, and this is the hypercube. So on the left, so you basically start with a line, and you start creating Cartesian product with another path graph. So you have a line which is a path graph, Cartesian product with another path graph, and you continue this operation. You get a square, cube, and then hypercube, and then so on and so on. And on the right there are some other examples where you use different products like tensor product and Cartesian product and so on. So all of these have actually very simple formulas, and you can just generate them in a split second. So graphs can be generated in a split second, but then of course the whole animation and unfolding is actually done in Rhino. So this is in a way the limit of Rhino. So here we have slicing on the left and stitching. So we start with kind of a Cartesian cube, and we remove some nodes, and on the right we kind of add the nodes. So we can use this kind of a basic Cartesian cube as a sort of a basic shape through which we can kind of subtract or add nodes. And then of course, again, because it's algebraically defined, we don't need to use even a cube to go from one shape to the other. We can actually transform between two lattices if they have the same underlying grid that kind of, so, you know, if you can go from A to B and then from B to C, then you can go straight from A to C. This is called, I forgot what the name of the property is called, but basically we can, so it's a simple kind of a transitivity, yes, thank you. So this algebra has transitive properties. Okay, so some things that we can do, reassembly, changing number of nodes. So here I paired two animations so that it runs a bit faster. So we're just removing nodes and adding them back together in different ways. Again, this is all Rhino. Some post-processing in Photoshop, but it's not real time. But yeah, you can create it in Rhino. This is again a little bit limit. Reconfiguration, so changing edge connectivity. So we have the same number of nodes, but we are changing how they are connected. And the whole topic here is a little bit this artificial morphogenesis. So I was actually interested in how to kind of simulate artificial biology. Okay, so in a way, these are basically lattices that kind of operate in some sense physical space. There are physical forces between them, and so we don't define actually the geometry at all. I hope this is clear. So we are not defining the arrangement of these nodes in space. We are just defining the graph, and the arrangement is reached through this kind of force applied approach. And again, there's an equilibrium. So at one moment there's an equilibrium and the shape is defined. So it's in a way potential, well, I would call it an emergent shape. Okay, transformation is transforming from one lattice to the other. And these are maybe the most interesting examples where again, we use, kind of tried to go here really as architectural as I could. Some of you might know this arrangement on the left. These are it's basically a square cubed grid with diagonal stiffening, okay, and yeah, then you're just kind of cycling between different graphs. Okay, and then the one on the right is going to kind of go back to its original shape. But maybe we don't run it that long. You can also check them all out. They're all online on the decentralized storage. So on EPFS, so they're slow to load, but in theory always accessible. Okay. And then this led into this protocell. So basically, we reached the limit with Rhino, and we wanted to create these structures, but in a browser using WebGL and make them interactive. So created these 3 collections for now. First one is called monocells, where we focus on lines or edges. Then a chromoplasm, where we focus on nodes. And then the third one is crystallics, which focuses on facets. So in a way, if you have a mesh, you have vertices, edges, and faces. Okay, so those are kind of 3 basic elements of a mesh. So these 3 collections are in a way showcasing one of these. Okay, and here again, pair them up. We created teaser videos for these. Again, these are all minted then on FX hash, and yeah, they're interactive in your browser. And this runs, I mean, rather fast. So you don't need to have a very special system to run them. And I hope in some of the videos you can see that when you see that they're kind of jerking, it means that you can actually grab them with the mouse and just kind of move them around. And yeah, on the left, monocells. In the middle is chromoplasm and crystallics collection is on the right, and each one has 250 pieces. And again, they're all unique, all different. And it was a kind of a very fun project, and we didn't reach the limits there yet. Okay. And then some explorations, but so they're going into the future. So we had actually one big commission from Robin Hood Coop, which is an organization in Finland that works on the intersection of finance, blockchain, Web3, and we created a membership token for them, which is still not deployed on chain, but they allowed me to show you this because it feeds into the story. So these are meant to be more like these kind of drawings that are kind of placed in paper, and they kind of transform between certain configurations. And Robin Hood Coop actually operates like a DAO, so decentralized autonomous organization. And the idea is if you purchase one of these, you basically become a member of the organization, and through that you can prove that you're a member. You can do voting, and there's some other benefits that come with that. So that's one use case maybe of NFTs, that they can in a way be membership tokens. Okay, and some other explorations that we did were these hypers. So in a way, just pushing this hyper ornamentation to the limit. This is unfortunately done kind of off, so not real time, kind of in offline rendering, again in Rhino. So there's some a very tiny collection that is now on object of these kind of hyper ornamented images, let's say. And then we wanted to now push it in the next step. This is actually the first time that I showed this in public. We managed to actually make it run in a browser. And huge thanks to Kane Borg, my partner, who managed to kind of pull this off. Okay, so this is WebGL running real time. These are just GIFs, but they run real time in a browser. And it's used this instantiated mesh geometry. And that's in a way, hopefully, our next project in the near future. Okay, and now the last part. So I have 10 minutes, which is great, maybe on time. AI imagery. So there's another workflow that we use, and I just want to show you a little bit kind of how we use it in practice. AI imagery. 2 quotes. I will role play them. First one is from Charles Baudelaire. A madness, an extraordinary fanaticism took possession of all these new sun worshippers. So Baudelaire is raging about people using photography in the 19th century because if you know a little bit about art history, you know that kind of the classical arts got a little bit of crisis when photography was introduced, because you had a whole profession of people basically doing portraits, okay? So photography came, every dimwit could kind of take a photograph of a person, so suddenly the question was, well, how am I going to make my living, okay? So there was a huge kind of shift in thinking, kind of what art is, and Impressionist movement was the direct consequence of that, because the Impressionists then said, well, maybe we are not doing, photorealistic portraiture, maybe we want to, paint and depict a mood, so it's not about the detail, it's about using color to paint light and kind of convey mood through this kind of a small image, okay? So they were kind of rethinking the disciplines that they were operating in. And another quote, just from recently, this isn't going to stop. Art is dead, dude. It's over. AI won. Humans lost. Okay, this is Jason M. Allen, the guy who won State Fair art competition by using Midjourney output. So there was an article then in the New York Times about it. Okay, so we talk about generative neural models. Frank Rosenblatt, so kind of the father of deep learning. Basically, all neural models in some way imitate the brain, or at least their initial inspiration for the model was how the neurons are wired in your brain. And it had its own ups and downs over decades, but turned out to be recently, in the last, let's say, 10 years, a very successful model, or kind of a principle to create a variety of models. And again, machine learning in itself is not really interesting for us, or at least not for me, if it's used for classification, for example, but I'm primarily interested in generative neural models. Okay, so the neural models that can actually that have a generative capacity, and there are more, but some of them that we used in our work is variational autoencoders, generative adversarial networks, and newest thing that at least I learned of, the diffusion models. Okay, so again, there are more, but these are the ones that I used in my work. So this was 2019, deep floor plans. So this is a variational autoencoder. So my brother Mattia, who is an expert, told me that this is like 1980s technology, is just running on faster computers. So you have kind of you're basically autoencoding in this case floor plans, and this is just one try that we did from a very limited data set. It contains a bit more floor plans, but basically you can already get kind of quite good results. And yeah, there are kind of issues there, but this was sort of our first exploration within the 10 studio of kind of how this technology can be used for architectural purposes. This one was actually done with Miro, Roman, and Petra Tunjanovic were there, and our #2 prized entry into the Biennale. Unfortunately, you don't get to build if it's #2, but this was for Venice Biennale some years ago, Studiolo, so in a way you can kind of expand, so this is just a start, but in a way you can expand it into a more spatial story by kind of applying certain other techniques. You can kind of start layer to layer approaches. And then this was the Machine in the Garden project, which we started in 2020. The output from a gun on the left, and just recently diffusion model on the right, 2022. So in 2 years, the technology just exploded. I mean, I hope you see the difference kind of between these two. Okay, so we talk about, so now I'm just going to talk about this latest generation of models, latent image diffusion. So image diffusion using text prompt to guide generation. So in a way, it's a neural network basically that is trained to denoise an image in incremental steps. And we additionally condition this network with a text using classifier-free guidance. And basically, these are the kind of recently, unveiled text-to-image generators, which literally exploded in 2022. In order of appearance, at least in order of my discovery, Mid-Journey, something like March, maybe of this year, April. DALL-E and Stable Diffusion, which is actually open source, so open source you can write on your system. Just some numbers from Stable Diffusion model. They used 2.3 billion images, text captioned, to train the neural network, and then additionally refined it with 600 million images with high aesthetic score. Okay, so they're not random images. They're like they were in a way the best images that you can find on different blogs and so on. 150,000 hours of computing in total, which so these are just numbers that I got from them. Around $500,000 market price to perform this computation. So the key here is that you cannot really train these models yourself. But once when they're trained, the execution is very fast, and the reason is linear algebra. Okay, so if I have to do backpropagation training on a neural network, this takes very long. But if I'm just doing forward execution, so linear transformation, so kind of propagating the data from the beginning to the end, that's called forward propagation. This is very fast, and actually our GPUs are constructed to do exactly that. Like your computer graphics, like the mesh rendering, that's exactly what it is. You're kind of using, just transforming the nodes in space and use linear algebra or specifically matrix multiplications. So in a way, we have this very lucky coupling of the hardware that is made for something completely else, like gaming, and in a way we can run neural models rather quickly. Okay, so hard to train, but easy to deploy and use. And that's why you can use these services and they spit out an output within seconds or 10 seconds. Okay, and this kind of lead us to a new workflow, which are called operative dreaming. So it's going from language imagery. Okay, so creation of visual narratives using language directly. So text prompts become spells in a way crafted to conjure visions. And maybe a little bit embellishing this, but I think it's kind of a game changer in the industry. Okay, small digression into dithering. I kind of got obsessed with this technique of dithering, and I applied it into many projects, also the protocells that you saw, and I just wanted to a little bit explain what it is. So the question is, what is the simplest element in graphics? That's how you start, and that's a pixel. Okay, so and there's an excellent artist that I follow, A.L. Crego from Spain. The way this shift from a point or circle in traditional art to kind of a pixel, which is actually a square. So in a way, if you're a digital artist, your smallest element is a pixel, not in a way a point, not even a mathematical point, okay? 1 bit. Okay, dithering is a form of intentional noise used to randomize quantization errors. In a way, in the words of Mies van der Rohe, famous architect, more is less. No, less is more. So you can kind of get more for less. More fidelity, less colors. It's actually a retro technique, so used in early computers to basically use less colors to get more shades. Okay, so you can, in this case, use just black and white pixels. So the minimum amount of colors that you can use, but you can still get the whole spectrum of shades. And you use this basically. So this dithering uses error diffusion to preserve average brightness of pixels on a local scale. And it's a rather simple algorithm to implement. This is actually in color. So it's in a way, I see it as a way to take the simplest element and construct complexity by giving it structure. And when I said that, I almost quoted, Louis Kahn, So kind of the idea, you take a simple element in architecture, a brick, and you put it on top of each other, and you create you create the world. So that's why I found this technique kind of very interesting. And then now we bring it together. Okay, so we have AI imagery and sort of dithering or sort of let's call it generative effects. And this is Glitchverse, the project that is not released yet, but it will be released very soon by Jared Scott and Protocell Labs kind of together for a brand new platform called Glitchforge. And yeah, there's a link down, and hopefully this month or maybe next month we will release it. So we talked about generative art. There's somehow an underlying theme, but also the effects that are applied are generative. Okay, so these are all just generative, basically glitching effects that use dithering and pixel sorting as their base. And yeah, we can have as kind of many as we want, and here it's also reduced a little bit to give it this retro aesthetics. And when you mint a token, you actually get a GIF. Okay, so you get a GIF, which is a digital format which is native to the internet, and maybe the first digital format that was native to the internet. Before internet, there were no GIFs. So in a way, if you use browsers, GIF is maybe the best. Because yeah, maybe the most native format to use. And these are just some examples from the collection. Dark in theme of Halloween. And the underlying art is text to image prompt generated. So specifically used Mid-Journey. So it's kind of a collage of things. Okay, but when you mint a token, you basically get a custom image and a custom effect kind of applied on top of it. And it's kind of a GIF loop. Okay, and then something similar we did also for, again, Robin Hood Co-op, kind of another commission, we call it Imaginarium. So they had another request for us. So they had this kind of a NFT membership token that they wanted us to create, but there was also, they also wanted to, first they wanted to create a branding. So they created this kind of branding for them, using, again, some kind of pixel effects. But in the end, the whole project merged into setting building. Okay, so they would like to basically create a workflow where they are building a setting specifically on kind of Robin Hood kind of legend, and we just dived straight into it because we believe we are competent in imagination. So we just created a kind of a series of these visions for them, and this is kind of a starting point, hopefully, for their kind of DAO and their engagement with the community. And here there's the Robin Hood faction, which use advanced technology, but they live in a forest and kind of coexist with nature. And then there's the Nottingham faction, which also uses advanced technology, but they use this to the detriment of their environment. And there's a conflict between these two, so kind of a factional conflict, a very general story. So two types of progress. Okay, and now we are basically at the end, and thank you very much.
Thank you, Luka. I would have tons of questions. It would take hours, but I will have the chance to talk to you later on. Before we move to the drinks, any questions? I think we can spend 10 minutes.
I have some low-level questions. You mentioned the word mint. What does it mean? I have no background in FE.
Okay.
But I went to your website. The whatever hash.
Yes. You cannot mint them anymore because they're all minted.
So what exactly is this minting process?
Okay, so when you release a collection, there's a certain number of pieces that can be minted.
And you decide how many?
Yeah, you decide how many. You have to connect your wallet, your digital wallet, so crypto wallet. So for example, you can use Temple for Tezos. MetaMask is the most popular for Ethereum, but Temple, Kukai for Tezos. You have to have money there. So Tezos is the currency. It's a real money, okay? You transfer some money to it, and then you can use your wallet, which is basically represent your digital identity. You can use it to mint, basically buy a piece. The piece doesn't exist before somebody buys it. When you buy it, you basically send the money, or you mint it in a way. The operation sends the money to the contract. The contract says, thank you very much. I will generate now a custom piece for you, and you will get it, and you get the token transferred to your address. So your address is basically your, in a way, location where your cryptocurrency and all the tokens will be sent to. So it's like a wallet. And yeah, and then the collection
minting process only happens one time.
So
I get the result of that function that you created.
So you can set a number of pieces that can be minted, 250 for example, and you can mint multiple, or many people can, you know, so usually many people mint, but you can also mint multiple if it's not a huge demand. When they're all minted out, they cannot be created anymore. The supply is fixed, and then they can only be exchanged. So you can resell your token to somebody else. So that's called the secondary market. Imagine an artist creating a collection of paintings, and you buy your painting, you get it, and then you can kind of resell it, which can be used for speculation, because sometimes you buy it from a famous artist, price goes up because there's a huge demand, you can resell it, you can make some money maybe, or you just keep it, and yeah, that's it. So
in general, I don't see the painting or whatever that artwork or gift it is before I pay.
yeah, exactly.
I don't see.
Yeah,
And
yeah.
the second-hand market is I see
Yeah.
what I'm getting.
Exactly.
Okay.
But you usually have to pay a higher price. So yeah, that's the kind of the idea of gen art, that it's basically there's an algorithm that will produce as many pieces, but you don't see them before.
But you as the artist who created this, you know what you're selling. You know what the first piece
I know
is.
what the no.
No. So that's also a random process.
So because what the algorithm does, it just, for example, takes some random information, for example, your wallet address, which I don't know who will buy, okay? And then some other information, concatenates it and creates a random seed for the pseudo-random generator, which is kind of embedded in the algorithm. So the algorithm is actually deterministic, but you can set the random seed of the system, and this is set for every minter separately. And that's why you cannot really predict what comes out. And that kind of ties back to what Tyler Hobbs was talking about, long-form generative art, because you cannot predict what's coming out. You have to make sure that even the crappiest piece that comes out is still kind of good, because otherwise somebody mints a piece, and this happens all the time, also to me. Piece comes out and you're just embarrassed. And then, yeah, and then you're like, I will buy it from you, and I'll burn the token because I cannot look at it, you know? So sometimes when mints come out, like even the famous artists like Zankan, maybe the most famous artist in Tezos, when the piece comes out like off, there's maybe a bug, he buys it off or offers to buy it from collector, get the money back, usually get some small thank you like another token, and he burns it because he cannot stand to have a kind of a faulty piece. There are some other approaches to this, also pioneered maybe by Tyler Hobbs, incidentally, that actually go around this problem. There are different mechanisms for minting. Also, Glitch Forged platform uses a bit different method called forging and smelting. And I think it's just interesting to see different approaches that you can have in creating, basically collectors being able to participate in the creation of the art piece. So it's kind of a very inclusive way of participating. And it's just developing, so.
Thanks.
I would just have a very small follow-up question. It was super interesting, thank you very much. How do you decide how many pieces you want in a collection? Because, and also how does this relate to, like, you know, if you're a painter, as you said, then yeah, you need some time to paint 20 paintings or so. If you're printing, you know, you have the physical constraints, you can make a series of 20 prints or so. But how do you define this size of the collection, and also maybe more out of curiosity, who is the buyers? Like, you know, do you have any?
Who are these people, you mean?
Yes, who are these people? Because, you know,
that's
there's
always
so
a
many,
question. Yeah, I know.
Words I've never heard before, and then.
So when I entered the space, I did not really ask myself who are the people. I just started publishing on Hick and Lunk back in the day, and one day, just discovery happened, and the pieces just started to fly off. And I'm a collector myself, so I actually buy pieces because I see it also a form of identity building. So some people buy art to put it on their walls, and so I'm a collector as well. I completely kind of dig it. I just don't have enough money to buy everything that I would. But I, for example, do own a hollow, one of the kind of cool pieces. So I have some expensive pieces there. But you know, so people who, yeah, I mean, you know, you buy, people play games and they buy skins for the game. You pay for digital services all the time. This is in a way just that. I mean, I see it as a way of identity building, but in a kind of natively digital way. Some people just spend a lot of time online. So that's where their friends are, communications, but there's also a lot of kind of real world gatherings. There are many conferences that you can go to and meet the collectors and network with artists. So it's in a way like an art world, just different crew.
The question is because one
The question was about
thing that
numbers,
you said is that a thing that the art world would not like is that it's quite transparent.
Yeah, exactly.
There, my question I will follow up to David's is, you know, are there players, and if yes, which ones are these players that can manipulate, not by hacking it, but just by, you know, suggesting that, you know, being a successful, you know, whatever, you know, because at least at the level of NFTs with the Bored Ape Yacht Club, it's all about this, you know. Just like today, you know, Eminem is very interested in letting everybody know that he has these things. We just push it up with value, you know. Is this a phenomena that, you know, affects the whole market,
Yeah.
or only very specific one where the superstars are collecting?
No. It affects all markets. There's a lot of speculation in space. Again, just everything that is, like many things that are true for the traditional art space, same here. So art can be used, you know, you can buy art because you just like it, or you can use it for speculation, so it's an investment. Some people buy art and yeah. So there's for sure a lot of that. And I mean, the biggest artists, their problem is that, you know, how to equitably distribute the art. Because if you have 300 pieces, but you're Tyler Hobbs, somebody will have a botnet that will try to mint all the pieces at the same time and then resell them. So how to ensure kind of equitable distribution is kind of a big topic in these big chains. So you have allow lists and so on. So you cannot buy more than one and so on. So there's also wash trading, where, you know, I have an art piece, and I sell it to Petrus for 100 francs, and then he sells it back to me for 100 or 200, and then I sell it back to him for 300, and then he sells me back for 500, and now we are listing this and like, look at this, you know. So this is called wash trading, and again, platforms are fighting against it. So there's a lot of that as well. Which should not kind of diminish maybe the value, it's just that tools have to be developed. I just want to answer your question, David, about the number of tokens. You can determine whatever number you want, but actually what should the number actually be? Usually you have to look at the variety of the pieces that you're getting, because you can have an algorithm that can produce infinitely many pieces, but they all look the same. So why have 10,000, you know? So in a way, this is sort of basically you have to do it a little bit by the feeling. If you do it wrong, then you will just have too many pieces, they'll look the same, and then the secondary market is just like boring, because what's the point in reselling a piece because they all look the same? Whereas if you have a high diversity of pieces, there is, for example, again, mentioned another artist, Suzankan, very famous, very popular also, and he collects from other artists, but only green pieces, everything that is green. There was recently an exhibition called in the so-called green rooms. All the pieces he collected, but they're all green. So if you want him to collect a piece from you, it needs to have a green tint to it, and so on. And yeah, I would do the same if I would have the money. I would focus on a color and then do it like that. Yeah. And there is also a whole ecosystem. The whole point of Web3 is that you can build tools on top to, so you know, the infrastructure exists, it's actually secure, so the NFTs are securely there on the blockchain, and you can create your own front ends, okay? So there are tons of tools out there for galleries, for metaverses, where you can kind of exhibit your pieces, for collection appraisals, just like tons and tons of stuff that you can just build on top. So it's a very sort of open source environment, and that's why it's, I think, also developing so fast, because yeah, for example, we at Protocell Labs, we might be interested now in building like our own collection, preview, and that's just gonna pull in the information that is already available there, just create our own front end. So it's kind of very easy to build these tools. Imagine just, this we don't have in Web 2. Okay, you cannot do this with anything related to Facebook, even to Google and so on. So we kind of really are moving from this sort of centralized models to sort of decentralized models. It's kind of an anarchist model, but my friend Josip, who is here somewhere, gave me an excellent example, of this decentralization. So internet, decentralized, but another institution that is 200 plus years old, decentralized, used maybe every day, every week, post office, okay? So if I deliver a brief across the world, it will be delivered. But the post offices, they just have they're not like one organization. They just have an agreement that if something comes from abroad, they will deliver it for free within the country, with the agreement that when we send something out, that other country will either transfer or deliver it there also for free. So you're only paying your own post in your own country. So it's a decentralized system that 200 plus years old, that completely works. Okay, so decentralization works. Wikipedia as well, and maybe payment systems should, digital assets should actually work the same way, and it's not that implausible at all.
Okay. There are two questions. One.
More questions?
Benjamin?
Thank you very much. Very impressive to see all the work. During your talk, you often mentioned analogies to the pre-digital world. You say it's like if I have maybe a written contract, or could you maybe highlight from your experience where you see the biggest, really fundamental difference in connecting the art to NFT tokens? So where do you see a categorical difference in your work, or is there any? Or in the work, not in your work specifically, but in general in the work with these digital contracts?
So relation of the kind of physical assets and
is it just that it's digital and more available, more distributable, or is there also, because there is art gallery system already, there is contracts already, you can also produce procedural art in series, so where do you see the biggest and most interesting difference for you in this work?
I'm not sure if I can exactly answer this, but I think, we are not talking only about digital applications. Just I mentioned before that you can actually tokenize physical assets, okay? And then, one application is, you bypass bureaucracy. So, I come from Croatia originally. If you want to buy property, you have to go through a whole system that is, hundreds of years old, that kind of validate, transfers the ownership. There's tons of fees in between. Whereas you could, if you think about it, even this kind of, the most physical of properties, the land, could be actually tokenized, and whoever holds the digital or can perform a digital signature is the owner, and this can even be, stated in the contract, so embedded in the legal system. So when I'm selling my apartment to my brother, for example, or vice versa, we just do a blockchain transfer. So it's a huge increase in efficiency, for example, which opens up tons of possibilities that, again, I cannot even go into. Then you can suddenly use these physical assets that are tokenized as a collateral for doing loans and so on in a completely decentralized way. Okay, so I can use the token or art that I have. Maybe I have a valuable art collection. I can actually get the collateral. I can use it as a collateral to actually get a loan from a decentralized service, and this is already possible. And I cannot do this with the bank, for example. So it just enables a completely different economy that is kind of rooted in the digital, but it's not purely digital economy. Maybe it doesn't answer your question, but yeah, kind of creates a programmable economy, and I believe it also has a potential in the ideal world to increase, maybe reduce, kind of increase equality in the world, and distribution, okay? Because the whole problem today is that there's so much value in the, you know, the tech stocks, the internet stocks, but it's all concentrated in very, very few companies. And as we learned also recently, with, you know, this concentration come also risks. So it doesn't look good. So, you know, maybe there's a better way.
Yeah.
There was a question actually here.
Yeah, I mean, coming from very inspiring talk and coming from very different background, I'm fascinated that you are saying there's a generative art is art, similar to art market, and then it's also but art market is in a way different, is very exclusive, manipulated by the galleries, the people who has like money.
I didn't say that.
Okay, maybe that's my impression. Okay, and then my question is the generative art, this kind of art, is it becoming more like, I don't know, the social influencers? Because then you said the more copies it becomes, it has, the value increases. So in a way that is a more inclusive, democratic way of judging if it's good art or bad art. How do it become popular? Is it a criteria also to see this is good and that is bad?
I'm not making any value judgment on art at all. I'll never talk about what's good art, what's bad art. I'll just talk about what I like or I don't like. I think it's a mistake to see these as kind of separate, even though now they are. Just because collectors that collect digital art, they never collected anything before, but they have a lot of money now. So, you know, they started collecting something that is easier for them. And I think in the future this will merge. So you will have, you know, already in the art world, when you talk about traditional art, it's not like one monolithic industry. So there's like, you know, there are different niches and so on. And this is just a niche that is currently a bit more separated. I think it will merge more, and it will get, you know, it will merge also with pop culture, because, you know, when Andy Warhol, okay, you know, pop culture was considered to be banalization of art. It was like, oh, these are like cheap copies, you know. So, you know, pop art is not art. That was, you know, some decades ago. But pop art is art, okay? So gen art, it's not art, but actually it is, you know. So what is art gets redefined, and it's a kind of a very fluid motion. I think just now we're just too close to it. It seems separate, but it will all kind of become part of it.
Pessimistic view also that the art market is totally capitalized, it's just capitalized.
I didn't say that.
And this will also become that, part of that, but not in a way that also gave a disruptive societal change.
Yeah, I cannot extend this discussion, I'm sorry, but
okay.
No, but it's, you know, we have speculation in any.
Yeah, but I have a last
but
question.
I understand your point. But it's hot potato. Last question, there was some.
Yeah, you actually already answered it in the beginning. But when you talked about using the hash of your wallet actually as a kind of random seed to generate the last one, when did you start doing that? I guess only with the very last ones that are actually running in the browser, right?
Yes, true, correct. So the ones that are running in the browser, the protocells, they're the ones that are actually generated on demand, and the previous ones were just videos that were uploaded, and they were actually multi-editions. So it's like the same token, but you can buy multiple editions of them. Imagine like graphic, you know, you have multiple editions, so-called multi-edition NFTs. These are kind of so-called one-of-ones, but they're part of a collection. And yeah, that's why actually we switched to this sort of browser-based generation, because I think that's the way to go. It's more interesting, more challenging, harder, and I wouldn't say the future, it's kind of the present, but it's just, it opens up a lot of other possibilities, maybe in context of kind of metaverses and so on, where these, you know, I could create a metaverse where you can come in and all of your tokens can now coexist, because we know exactly how they're created. We have the, you know, pseudo-random generate PRG pseudo-random generated seed. Okay, so we have that, and we can just recreate everything on every token on demand. So we can start kind of merging them and so on. That's how these metaverse galleries are created, and so on. So yeah.
I'll take the privilege of the last question. Then,
Yes.
It bit relates well to the question on the art, and you know, my question is, from your inside now perspective, how close are we from the point where this technology just gets, you know, englobed, internalized in normality, because this has happened with other technologies. So when we talk about the internet, 1, 2, whatever, but let's say 1, these were very specific things that you were experiencing. If you were working in a university, then you were, you know, so close in contact with things. I remember we were writing servers, you know, that were doing these things, and the product up there were not very much more technologically refined. And then in just a few years, this has become the normal, although people did not understand it. So the people that then suddenly understood how to use the internet and what this would mean were not absolutely able to, you know, look behind the mechanism of, and the protocols of what would happen with a mail, you know, that they were able to send or to receive. It was sort of magic, and I guess that here a similar thing will happen, because the last since Bitcoins, first time I heard Bitcoins, I wanted to buy some Bitcoins, you know, but I failed with the, you know, process of getting the money. And probably each one of us has this experience. We'd all be very rich if we would have, you know, spent the night finding out how to get, you know, this crypto wallet, you know. But probably now we're very close to the point where you just have it, you know, and you don't think of what this means and what's behind and all this mechanism. Is this 1 year away, 5 years away?
You're one global recession away from it.
Okay, so the next one will be the good one. Okay.
Yeah, that's what happened with the internet. You know, there was a dot-com crash, and then on the other side emerged, I mean, Google was right there, but Facebook, YouTube, and so on. So we are, you know, potentially five years away from it. I think it is true that in the early days it was very hard to interact with blockchains, and that's why kind of, you know, you just couldn't do it unless you were a hacker yourself. But today already it's super easy, and that's actually the main reason why, for example, I'm using Tezos. It's very cheap to kind of onboard yourself, and it's amazing to think that there's kind of money in your browser. It's not in your browser, but you can interact with it. Otherwise, you always have to take a credit card. And when I realized this, that you can just load up some money there, and then you can just directly from the browser, you can start buying things. It's an add-on to your browser. It actually makes it very easy. And yeah, way easier than a credit card, way safer than a credit card, for sure. That's why I use it for tons of stuff. We do, so in PEN, we pay each other honorariums also over the blockchain, because it's just easier than do bank transfers maybe. Okay.
Then thanks a lot.
Thank you very much. Opera is open.